Okay, this is factoring a trinomial with a leading coefficient other than 1. Looking at it here, I have 2m squared plus 3m minus 27. So my factor bubbles down here, I will be multiplying and getting a negative number and adding and getting a positive one. So what that means is I will have one positive and one negative here between our little binomials. What I have here for my 3m being positive, that means my positive, whatever number is coming in this little spot, is going to be bigger than that one, so that as I add a positive with a negative, I end up with a positive answer. So let's set that concept aside. It is very good as you are thinking through any mathematics to have a clue what the answer should look like, what an estimate should look like, so that as you get to the final example, the final answer, you would have an idea if you're missing a step. Okay, let's keep going. So here's how you factor a trinomial. We have got ax squared, bx, and c. So these are generally how we call our terms. Whatever is with our squared term, that guy's a. Whatever is with our plain term, that guy's b, and our last constant is c. So I'm going to come right over here to this lovely little t-chart. This is a times c and b. I need two numbers that when I multiply give me a times c, and when I add give me b. My two numbers there are 27 and 2. 27 times 2. A is 2, c is 27, negative 27. And when you get into the higher level math, take a moment and go back and make sure you're getting this right. I don't want you to make any mistakes here. So let's go up here and just do this math real fast. 2 times 7 is 14, drop the 4, carry the 1. 2 times 2 is 4, plus 1 is 5, and we have 1 negative, so it would be negative 54. I'm looking at negative 54 here on the a times c, and my middle term is 3. So here's what I'm looking for. I'm looking for factors that when I multiply give me 54, and when I add give me 3. So looking at that one, of course I could do 1 and 54, that would work, to multiply and get 54, but if I added, would that give me 3? No, so it's not this one. Let's look at how about 9 and 6. If I multiply 9 times 6, would I get 54? Absolutely. And wait a minute, let's see, that's a negative 54. So I need, as I'm adding these guys, how about if my 6 were negative? Let's check that one. 9 times a negative 6 is a negative 54. 9 plus negative 6 is a positive 3. Perfect, that's it. So 9 and 6 are our two middle terms there. So here is how our steps go from here. We're going to look at this by factoring by grouping. I'm going to take my beautiful first term here. That is my 2m squared. And I've got my split of a middle term here. Instead of just plain old 3m, I'm going to write that as 9m. And we also have our negative 6m. I had to catch myself there. So it's negative, and I almost started writing a positive. So as you're working with all of these numbers, watch yourself for making sure your positives stay positives, your negatives stay negatives. Our middle term, instead of just plain old 3m, we split it into 9 and 6. And then we also write down our last term, our negative 27. Let's go back to purple. Okay, so looking at us now, I have 1, 2, 3, 4 terms. 1, 2, 3, 4. Whenever we have 4 terms, we're going to factor by grouping. So as I look at these first two terms, I see a 2m squared, a plus, and a 9 and an m. Well, all that has in common is an m. When I factor an m out, that gives me 2m plus 9. Remember, you don't have to get any of these wrong. You can always go back and check. So if you have a number outside of parentheses, that gets distributed by everything inside the parentheses. M times 2m is 2m squared. M times 9 is 9m. Cool. I know that I factored that correctly. Let's look at our second two terms here. I know I'm trying to hopefully make a little twin here with my 2m plus 9. So I'm going to pull out a negative, let's see, it looks like a 3, the most they have in common. When I factor out a negative 3 from negative 6m minus 27, that gives me 2m plus 9. Perfect, just what I was looking for. Again, we can make sure we got that right. Distributing that back out, negative 3 times 2m is negative 6m. Negative 3 times 9 is a positive 27. Perfect. So if we remember factoring by grouping here, one of our factors is what we have in common, that 2m plus 9. So that's going to be one of our factors. And then our second one is our m and our minus 3. We pull these two little front terms here, and they get to live in their own little factor bubble. And what did we say from the beginning, right? Didn't we say that our plus is going to go with the larger of the two numbers. Let's look at that. Cool, it does. So we have our positive 9 and our 3. Again, you don't have to get any of this wrong. We're going to remember foiling. Remember FOIL? Our first, our outer, our inner, and our last. Our first two terms multiplied together gives me 2m squared. Our outer two terms, 2m times a negative 3 gives me a negative 6m. Our inner two terms, that gives me our positive 9m. And our last, that gives me a negative 27. What we do at this point is we're going to gather our like terms. I have m squared, so 2m squared. Let's look at m's. I actually have two terms that have just a plain m with it. That is going to give me a positive 3m. And then I have my last term, which is a negative 27. So we factored it back out. They match each other beautifully. Put a box around your final answer. 2m plus 9 and m minus 3 are our two factors. So let's take just a minute and look at a really cool cheat sheet shortcut we can take here. Let's go back in time. I'm going to get a clean piece of paper. Let's start with our original here. Our original problem, again, was 2m squared plus 3m minus 27. Okay? And we did our a times c, which equal b, and we said that this was a times c was a negative 54, and b was 3. And we looked at that and we said, okay, well, the two terms that work there are 9 and negative 6. So here's what we're going to do. We're going to play a little game. Here are the rules of the game. Number 1, if it reduces, reduce it. Number 2, if it does not reduce, pop the denominator in front of your variable. So as you're writing, as you're taking notes, taking a moment to write those two steps, and you're saying, well, where did these two steps apply? Well, let me show you the game. So we know our two rules of our game, right? So we're going to make our factor bubbles. Nice, big, fat, open factor bubbles, okay? The letter we're working with is the letter M. Not X this time, they're using M. Sometimes you're going to use X, M, T, N, F, any variable that your writer wants to write, we're going to use, and in this case, it's M, okay? Now here's what you're going to do. See this beautiful 9 and this beautiful negative 6? Put them in there. I got a 9 and I got the negative 6. If you are working with a coefficient other than 1, this beautiful 2 we have up here, this guy comes down and we're going to put him under each of these numbers. Okay? So just as we did before, we found our 54 and our 3 and we split the terms. And here's what you're going to do with them. Write each of them down and then take your coefficient and put it under each of them. Now let's play our game. If it reduces, reduce it. Negative 6 over 2 reduces to negative 3. So I have one factor that is m minus 3. 9 halves, that won't reduce, won't get any smaller than that. If it does not reduce, pop the denominator up in front of the variable. So our second factor bubble is 2m plus 9. And let's go back and look. What did we have before? 2m plus 9, m minus 3 with our shortcut, 2m plus 9, m minus 3. Let's prove this two more times here. We'll keep our rules handy. Here's our second example. We have 5x squared minus 14x plus 8. So again, let's take just a second here and think about what we're looking for. I need two numbers that when I multiply give me a positive number, but add and give me a negative number. Well, the only way to do that is two negatives, because remember, a negative times a negative is going to give us a positive answer. Okay, so we know what we're looking for here. Two negatives to give us our beautiful positive answer. Now let's do it the long way. We have our ax squared, our bx, and our c. So we know what our terms are, of course. So we have got 5 times 8, which is going to be 40. I need two numbers that when I multiply give me 40. This is my a times c. And I need two numbers that when I add, they give me my b term, which is a negative 14. So, yep, looking at it, I can do 1 and 40. I can do 2 and 20. So far, I haven't made my 14. I could do 5 and 8. Nope. But how about 10 and 4? Yes. Cool. 10 and 4 work. A negative 10 times a negative 4 gives me a positive 40. A negative 10 times a negative 4 gives me the negative 14. These are my two terms. Okay, long route. First term, 5x squared Last term, positive 8. Splitting our middle term, the negative 14x, we're going to call that negative 10x and negative 4x. And we got that right from here. Okay? So let's 1, 2, 3, 4 terms. When we have 4 terms, we're going to factor by grouping. Between the 5x squared and the negative 10x, they have, oops, let's try that again. We have 5 and x in common. When I take a 5 and an x away from the 5x squared and the 10x, that leaves me with x and a minus and a 2. Again, we can go back and check as I distribute here. 5x times x gives me 5x squared. 5x times negative 2 gives me negative 10x. Perfect. I have factored that out correctly. Looking at our second 2 terms here, between negative 4x and 8, I can factor out a negative 4, which gives me x minus 2. Hey, awesome. We have got our twins, our beautiful matching factors here. So I know that one of my answers is x minus 2. That's what they have in common. And my second factor is 5x and the minus 4. So here is our final answer on that. Again, we could FOIL it back out and we would get this beautiful trinomial. Let's play the shortcut game again. Nice fat factor bubbles here. I have got negative 10 and negative 4. Our variable we're working with is x, so we'll throw those x's in here. And we have our coefficient of 5. Okay, you have to deal with this last step, the leading coefficient of 5. So remember, 5 is going to come on down. And I'm going to drop it beneath each of our terms there, each of our constants. Going back over the rules, if it reduces, reduce it. If it does not reduce, pop the denominator in front of your variable. So let's play that. 10 over 5 is 2. So this one is x minus 2. 4 over 5, the 5 is going to not reduce. 4/5 is not going to reduce any further. So the denominator pops up in front of our variable there, 5x minus 4. And as I say in my math class, oh, would you look at that? Nice shortcut. Let's do it one more time. Our third example is 10m squared plus 23m plus 6. Thank you. My assistant handing me my purple pen. Okay, remember what we got here. I've got the ax squared, I got the bx, I got the c. I'm going to draw my little t chart over here. I know we got a times c. I have to multiply, and I've got b, and they've got to add. So a times c, 10 times 6 is 60. My middle term that I need to add, that's a 23. Should have slightly better handwriting here, 23. Okay, numbers that make 60 would be 1 and 60. It would be 2 and 30. It would be 3 and 20. Aha! 3 and 20. Remember what we talked about as we started this show? This lesson here is thinking ahead. I need numbers that when I multiply give me a positive and when I add give me a positive, so they both have to be positive that we're looking at there. So just kind of a nice little clue here. Just as in your lower elementary years you did a lot of estimating, getting that good idea of what your answer should look like is so important. We know we're dealing with positives here. Okay, let's do it the long way. We have our first term, our 10m squared. We have our last term, our 6. We have split the middle terms into positive 3m and a positive 20m. So instead of 23, we split it into 3 and 20. That's what we figured out, that when you multiply 3 times 20 gives you 60. When you add 3 times 20, it gives you 23. Okay, 1, 2, 3, 4 terms. That means we factor by grouping. 10m squared plus 3m have an m in common. Let's say that without babbling here. I've got an m in common on that guy, and so I'm going to pull out an m, which leaves me with a 10m and a plus and a 3. Okay, so let's do our second 2 terms. What do they have in common? Between 20m and 6, the most they have in common is 2, actually. So let's look at that one. When I take 2 out of 20m, that leaves me with 10m plus and 3. And hey, perfect. They made our little lovely factor twins here. So I have got 10m plus 3 is one of my factors. My second factor is our m plus 2. Remember, we got that from our m and our plus 2 get to live in their own little factor bubble, and then the twin gets to live in its bubble too. Okay, so here is our answer, doing it the long way, where we split the middle term and then we factor by grouping. Let's do this the shortcut way again. So we do the nice wide fat factor bubbles. We ignore this middle part and pretend we were just at the beginning here. We looked at our 10 and our 6, our 60. We looked at our middle term, which is our 23. We figured out it was 3 and 20. So we're going to write 3 and we're going to write 20. Okay, we have our leading coefficient of 10. That's going to travel on down here and go underneath both of these numbers. Going back one more time to our rules. If it reduces, reduce it. If it does not reduce, pop the denominator in front of your variable. So just rules of our nice little shortcut game here. 20 over 10 reduces to 2. 3 over 10 does not reduce, so this 10 is going to pop up and come in front. So I've got 10m plus 3. And I have our other one, which is our m plus 2. And yes, as we say in mathematics, oh, would you look at that? Now, quick question for you. This first answer was m plus 2, 10m plus 3. The second answer is 10m plus 3, m plus 2. Is it okay that those are switched? Absolutely. Multiplication is commutative. 2 times 3 is the same thing as 3 times 2. Either way, you're going to get the answer of 6. Thank you very much.